In this lesson, we're going to go over part, percent, whole, and some applications. So our goals are to understand and identify in a given problem what the part is, what the percent is, and what the whole is. Usually what happens is we're given 2 out of the 3, part, percent, or whole, and then we need to correctly calculate the third, and we'll apply part, percent, whole to some application problems. So what we mean by part, percent, whole are problems like this. What is 52% of 598? 81 is what percent of 292? And then as an application, sales tax on a purchase. Sales tax is about 8.38%, so you'd be calculating 8.38% of the total value. So again, in problems involving part, percent, and whole, you're typically given 2 of the 3. So you're given part, percent, or whole, 2 of those, and you're asked to find the third or the missing value. So there's 2 strategies that I'll go over in order to calculate these types of problems, and then we'll do some examples. The first way is to use this triangle, the part, percent, whole triangle. So the part goes in the top, the percent, and it's very important, as a decimal. So we learned how to calculate from percentages to decimals, so you would use the decimal form of the percent in this triangle and the whole. So the way that it works is you fill in each part with the giving values. If 2 values are on the same level, you'd multiply to find the third. Or if 2 values are on different levels, you divide to find the missing value. And then again, you must work with the percent as a decimal. I'll give you way number 2, and then we'll do an example using both ways. So way number 2 is to use is over of equal to the percent over 100. So is another way of saying part. Of is another way of saying whole. And so is our part, of is our whole percent, and it's not as a decimal. So if we're talking about 20%, you would just put 20 there. It's already out of 100. And then you'll solve for the missing value using cross multiplication and division. So example number 1, what is 80% of 10? Okay, so in this case, the number with the percentage is our percent. So as a decimal, this is 0.8. So it would go in our percent part of the triangle. Of 10, so of denotes that we're talking about a whole. Okay, and then we're looking for the part. According to how this way works, if 2 values are on the same level, then we multiply to find the missing value. Okay, so we would take 0.8 times 10, and this would just give us 8. Okay, using the other method, is over of is equal to percent over 100. So what is, that's our question mark, that's what we're trying to find. Of is 10, and our percent is just 80. So the way this method works is we have to use some cross multiplication. So we cross multiply, so 80 times 10, and then we cross the other way is equal to question mark times 100, and we would be solving for the question mark. Okay, another way to think of this is you take 10 times 80 and then divide by 100. Okay, and that's what's happening if you solve for the question mark, and you get 8 that way as well. Okay, so that's using the part, percent, whole triangle. The other is using proportions, or the is over of equals percent over 100. And then I do want to give you a visual as well. So if we're talking about what is 80% of 10, remember that when we talk about percents, it means per 100. So I'm going to draw a big square, and again, pretend it's going to be 100 equal pieces. Okay, I'm using the edges as part of my square. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and again, 4, 5, 6, 7, 8, 9. So I have 100 squares. And to find out what each square represents, we take our whole and divide it by 100, which would give us 0.1. That means each of these squares represents 0.1. Okay, so I'm not going to write this 100 times. Pretend the whole thing just magically fills up with 0.1s. If I'm taking 80%, that means I'm taking 80 out of 100. That's what the percent is meaning. So it would be all but 20 of them. Okay, so you would take 0.1 plus 0.1 plus 0.1 plus 0.1 80 times, and you would still get 8. So that's a visual example as well of how to figure these out. Okay, We'll mainly be doing application problems in this class, so let me move on to that part. So my suggestions here to grab the math out of the problem. Anytime you're given a word problem, it's up to you to pull the math out of it. Okay, so with part, percent, whole applications, identify what's given, part, percent, and or whole, find the missing value, and then make sure your answer makes sense. Your answer should be reasonable with these application problems, okay? So application number 1, you order from DoorDash. The total cost of your order is $65 and you decide to tip 20%. How much should the tip be? I would read it again. I usually encourage students to read word problems at least twice. Okay, so we have the total, so that's the whole. And we have the percent, as a decimal would be 0.2. How much should the tip be? That's the part. So you're tipping part of the whole, and that's how we're getting this as a part, percent, whole problem. So if we use our triangle, part is what we're missing, percent is 0.2, whole is 65. So we would multiply, and this would give us 13. And then we check to make sure our answer makes sense. Does $13 on a $65 order make sense? It definitely should not be over 65. It should be less than half of 65 because we're tipping 20%. So I would say yes, this does make sense. Okay, you could also use is over of equals percent over 100, and I'll just write that out. Is what we're looking for, over 100, and that's what you would solve for that one. Going to the next one, at a particular college, 90% of the undergraduates are female. If 4,320 women attend the college, how many total undergraduates attend the college? This should say women, okay, attend the college. So this one is a little bit different. Let's read it again. At a particular college, 90% of the undergraduates are female. If 4,320 women attend the college, how many total undergraduates attend the college? So when it says how many total, this is what we're looking for, the whole, and that's what we don't know. This is part because 90% of the whole is the part, which is what we're given here. And this is our percent as a decimal. Okay, so if we set up the triangle, we're looking for the whole in this case. The part goes on top, and our percent as a decimal goes in that lower left hand. So if two numbers are on different levels, we divide. Okay, so we would take 4,320 divided by 0.9, which would give us 4,800. Okay, so what we would be claiming is 4,320 is 90% of 4,800. To check if this makes sense, if we're talking about 90% of something, that is close to all of it. So I would say, yes, this does make sense. 4,320 is 90% of 4,800. And you can always check too. Take 4,320 divided by 4,800 and make sure you get 90%. Okay, so this 4,800 is our final answer. Okay, let's talk about percent of versus percent increase or decrease because these terms can be a little confusing. So looking at the left-hand side first, percent of a number. So 100% of a number means that the original number stays the same. So let's say I had 50 students at the beginning of the semester and I still have 50 attending. That means I have 100% of students attending my classes. Less than 100% means the original number has decreased. So let's say I am down to 46 students. That means I would have 80% of my students attending my classes, and then more than 100% of a number means the original number gets bigger. So if I say I have 150% of students attending my classes, that would mean in this case 75, but really just the number is bigger, okay? Percent change, so this is where we talk about increase and decrease. So 100% increase of a number means the original number has doubled. Okay, so my puppy's weight increased by 100% since she was 6 months old. She was 7 pounds, now she's 14. So see how that's doubled? I can say that's 100% increase from when she was 6 months old. An increase of more than 0 but less than 100 means that our original number has increased but not quite doubled yet. So my puppy's weight has increased by 60% since she was 10 months old. She was 8.75 pounds, now she's 14 pounds. So it's not quite double, but it is bigger. Okay, so that's where we talk about between 0 and 100% increase. A decrease of more than 0 but less than 100 means the original number has decreased but has not reached 0. My puppy's weight has decreased by 30% since January. She was 20 pounds, now she's 14 pounds. We stopped feeding her holiday food. let's say, okay, but a decrease of 30%. It didn't go down to 0, but the original number has decreased. So what we can take from this is looking at the top, 100% of the original means it has doubled. That means a 200% increase means it has tripled. Okay, a 300% increase means that it has quadrupled. Oops, and so on and so forth. Okay, so a tangible example of this. So let's say a $10 item increases in price to $20. There are two ways to describe this change using percentages. The new price is 200% of the old price, and we would get that by taking 20 divided by 10, which would 2, change it into a percent to give us 200%. Or the price increased by 100%. So notice the different words, percent of, increased by a percentage, increased by 100%. So we have the original, and an increase by 100% means that we're adding the original total, or that the original number has doubled to give us $20. Okay, so thank you for watching. There's a couple of resources available on campus. You can always contact me. There's free tutoring, and then we have academic success coaches that can help with study strategies, learning strategies, test taking strategies, and things like that. So if you have any questions, please feel free to reach out to me.